Most people solve this problem in O of n log n, but there's a hidden O of n solution, and the trick is just one frequency array. Want full solution? Check this video.
Hi everyone and welcome back. Most people solve this problem by sorting the array first, but that actually makes the solution slower. In this video, I'll show you a true linear time solution in O of n using a very clean counting trick. Today, we will solve the leetcode problem to check if array is good. And this is actually a really nice problem for practicing validation logic and frequency counting. So the problem says that we have an array nums. An array is considered good if we have two conditions. It contains all the numbers from 1 to n minus 1 exactly once, and the number n minus 1 appears twice. For example, if our nums array has a size, let's say n equal 5, then the good array should look like 1, 2, 3, 4, and 4. So we have all the elements, all the numbers from 1 to n minus 1 that appears exactly one time, and the number n minus 1 appears twice. So 1 appears once, 2 appears once, 3 appears once, and 4 appears twice. Anything else is invalid. So how do we verify this efficiently? The key idea is we count how many times each number appears. Then numbers from 1 to n minus 2, we make sure that it appears exactly once, and n minus 1 must appear twice. So let's see that in the code. First, we will define or store the size array. So we'll define a variable called n. It will have the nums.size that is store the array size. Then we create a frequency array. Let's call it count. So define a vector of int. We call it count of size n and initialize all of its elements to 0. Note that we use size n because valid numbers only go from 1 to n minus 1. Now we iterate over every element in the array. So for auto num in nums, first thing we check whether the number is too large. So if num is greater than or equal to n, that means that this number is beyond the boundaries of the array. So we return false. So for example, if n equal 5 and we have here number 6 or 7 or greater than that, that means that this number is invalid and this array is not good, so we return false exactly. You may wonder why we are not checking the numbers below 1, and this is because here we have a constraint that num of I starting from the number 1. So we don't need here to check for this condition. After that, we need to handle numbers smaller than n minus 1. So if num is less than n minus 1 and count of num is greater than 0, then we return false. So here we check all the number that is less than n minus 1 and make sure that it appears twice. So if the count of num is greater than 0, that means that we need to return false immediately. So now we need to handle the special case where the number is n minus 1. So we check if our num equals n minus 1, and again the count of num here is greater than 1, then we return false. This number is allowed to appear twice, but if we see it more than 2 times, the array is invalid and we return false immediately. Finally, if none of these conditions returned, we update our frequency array. So count of num plus plus. And finally, we need here to return 2. So if we finish the entire loop without returning a false, this means that every condition was satisfied and we return it true here. So let's run it to make sure that it works correctly. Let's submit it. So as you can see, this solution is efficient because we only traverse the array once and every operation is constant time. So the overall time complexity here is O of n. And the space complexity is also O of n because we are defining here the frequency or the count array. And this is actually better than the sorting approach. A lot of people sort the array first, but sorting costs O of n log n. So even though the sorting solution may use less memory, your runtime becomes slower. This frequency count solution is the true optimal solution in terms of time complexity. And that's it for this problem. If this explanation helped you, don't forget to like the video and subscribe to the channel, and see you in next video.